So let us now discuss about one-sided limits. For one-sided limits, we have the so-called right-hand limit. The right-hand limit is denoted by the limit of f of x as x approaches a from the right. Take note of this new symbol. X approaches a sup positive. No? This is equivalent to x approaching a from the right. Meaning to say, your x values are greater than a. So on the number line, if this is your a, your x values are coming from the right of a. So it's called the right-hand limit. How about the left-hand limit? The left-hand limit. The left-hand limit is denoted by the limit of f of x as x approaches a sup negative. It is not equivalent to negative a. No? The superscript means that the x values are less than a. And this expression is read as x approaches a from the left. So for the right-hand limit, x approaches a from the right doesn't mean that x is positive. No? X approaches a from the right means that the values of x are greater than a. For the left-hand limit, x approaches a from the left, or x approaches a sup negative, the superscript is negative, doesn't mean that x is negative. That is wrong. That is wrong to say that as x approaches a from the left, x is negative. It means that x is less than the number a. So the number line, if this is your a, the x values are coming from the left of a. Alright? All the limit theorems are still valid. All the limit theorems are valid if x approaches a is replaced by, change that, replaced by x approaches a from the right or x approaches a from the left. So the substitution method that we use in evaluating the limit is still valid if we use, or if we are to evaluate the one-sided limits. And there is one important theorem about one-sided limits. The two-sided limit of f of x as x approaches a exists if and only if the limit of f of x as x approaches a from the right and limit of f of x as x approaches a from the left both exist, and at the same time the limit of f of x as x approaches a from the right is equal to the limit of f of x as x approaches from the left. So the ordinary limit that we know will exist provided that the right hand and the left hand limit both exist and must be equal. So Hence, if limit of f of x as x approaches a from the right is equal to the limit of f of x as x approaches a from the left equal to L, then the two-sided limit of f of x as x approaches a must be equal to the common limit L. Okay? The ordinary limit that we have exists provided that the right hand and the left hand limit both exist and are equal. So, that follows that if the limit of f of x as x approaches a from the right is different from the limit of f of x as x approaches a from the left, then the limit of f of x as x approaches a does not exist. What do we mean by that? So for example, the limit of f of x as x approaches 2 from the right is equal to 4, and the limit of f of x as x approaches 2 from the left is equal to 3. Therefore, the limit of f of x as x approaches 2 does not exist. It's just like this. From the left, it approaches the number 3. But from the right, it approaches the number 4. Okay? So supposing that is your f. As x approaches the number 2 from the right, the value of f that is being approached is the number 4. As x approaches 2 from the left, it approaches the number 3. So there is no common endpoint, no, for the interval negative infinity to positive 2 and from 2 to positive infinity. They do not meet at a common point. So therefore, there is no limit as x approaches 2. F has both the right hand and left hand limit. Yes, no? They both exist. But since they are not equal, we cannot claim that f also has a limit as x approaches 2. It will only have a two-sided limit, provided that the function or the graph ends up at the same point. There. That is your f, and that is your a. As x approaches a from the left, it approaches the number L. As x approaches a from the right, it also approaches the same number L. So this one, the limit of f of x as x approaches a does not exist. While in here, the limit of f of x as x approaches a exists and is equal to the common limit L. Alright? Okay. So for the given function f defined by f of x equal to 4x if x is less than 2 and 3x minus 1 if x is greater than or equal to 2, we evaluate the left hand and the right hand limit of f as x approaches 2 and determine also if the two-sided limit exists. So first, the limit of f of x as x approaches 2 from the left. So limit of. So the expression x approaches 2 from the left indicates that x here is less than 2. And for x less than 2, the definition of f is, for x less than 2, the definition of f is 4x. So you evaluate the limit of 4x as x approaches 2 from the left. Then, apply the limit theorem. And for this, by substitution method, the limit of 4x as x approaches 2, again, be reminded that this is not negative 2. No? The negative sign, the symbol negative above the number 2 means that x is approaching the number from the left. So 4 times 2, that will be equal to 8. How about the right hand limit? The limit of f of x as x approaches 2 from the right. So here, x approaches 2 from the right means that x is greater than 2. And for x greater than 2, what is the definition of our f? For x greater than or equal to 2, that is 3x minus 1 as x approaches 2 from the right. So evaluate this as an ordinary limit. So that will be 3 times 2 minus 1. 6 minus 1, that would be 5. Okay? So, we can now answer the third one, the limit of f of x as x approaches 2, no? The two-sided limit. But we state here, since limit of f of x as x approaches 2 from the left is not equal to, obviously they are not equal, 8 and 5, not equal to the limit of f of x as x approaches 2 from the right, our conclusion is that, therefore, the limit of f of x as x approaches 2. So let us be clear on this. X approaches 2 from either side does not exist. Okay? So let us have another one. Let me see. 2x minus let me see. Okay. So for the given function here, let us determine the left and the right hand limit as x approaches -1 and also the two-sided limit. So first, the limit of f of x as x approaches -1 from the left. Again, x approaches -1 from the left means that x is less than -1. So yeah, this part is very important because that will determine which part of the definition are you going to use in evaluating the limit. So if x is less than -1, then it should be the limit of -2 as x approaches -1. And the limit of the constant -2 as x approaches -1 is -2. Then, the limit of f of x as x approaches -1 from the right. It means that x is greater than -1. And for x greater than -1, we shall be using 4x plus 2. The part of the definition for x greater than or equal to -1 is 4x plus 2. So as x approaches -1 from the right, then we do the substitution method. 4 times -1 plus 2. -4 plus 2 is -2. Okay? And we see that since the limit of f of x as x approaches -1 from the left is equal to the limit of f of x as x approaches -1 from the right, equal to -2. Therefore, the limit of f of x as x approaches -1, take note, it has no more superscript, no? It's simply -1. X approaches -1 is equal to -2. Alright?